If you're ready to do math today and you have your coffee ready, join me in the simultaneous sip. The question we're working on today is, determine where the following function is discontinuous and why. So we want to find where our function is discontinuous. And if we look, each part of our function is continuous on their domains. So the only possible discontinuities is when we change the parts of our function. So at x equals 1 or at x equals 3. So let's start by looking at x equals 1. We'll start by taking the limit as x goes to 1 of our function. And now notice our function behaves like the top part when our x value is close to 1. So when we evaluate this limit, we could treat f basically as the rational function. That's our first part. And so to evaluate this limit, we're going to want to factor the numerator and factor the denominator and cancel out whatever we could cancel out. And luckily, we could cancel out x minus 1. So now, to evaluate the limit, we just plug in x equals 1 and we get 5. And now notice our function, when we evaluate at x equals 1, is also equal to 5. And so since our limit is equal to the same thing as just plugging in the function value, we say that our function is continuous at x equals 1. And the way we formally write it is this: the limit as x goes to 1 of f of x equals f of 1. And now we'll do the same thing with x equals 3, but notice there's no part of our function that is defined when x equals 3, so it's automatically discontinuous at x equals 3. Make sure to subscribe for more Coffee and Math with Dr. Weselcouch. Don't text and drive. Bye-bye.